Is larger diameter, stronger coil tubing capabilities part of the equation of what you're able to do in this record-breaking project?
Yeah, on that particular job we used, it was Legend, it was a coil tubing company out there, and they were using what they called a tapered string. It was a new string. It was 2-inch OD, but because of that coil tubing and because of some other processes that we go through as far as pumping beads and pumping pipe on pipe, if you will, to help coil get down, you know, they were one of the keys to our success as far as getting to depth. We run what we call a tubing force analysis on every job. It's a TFA. So what we'll do is we'll get the Wellbore Profile, and we put this in a model, and that model will tell us how far we can get out in a particular well. And typically the models are very conservative, and there's these friction factors that you have to put in the models, and, you know, and we are very conservative on our friction factors. The coil tubing company also does their model. They're usually a little bit more aggressive than us, but that's okay. They do for a living. But a lot of times a model may tell us that we can only get to 16,000 foot total measured depth. But because of the other processes that we go through, again, using a pipe on pipe, which is basically a slickum to help that pipe slide in a wellbore to where the coil tubing is not trying to buckle on itself. We also pump beads, which will help the coil tubing slide. And the other thing we do is we'll use the frac pumps to help pump us down as well. Okay? So we've got 3 different things that we can try if for some reason we stop or we friction out before we kind of give up and say we can't get to that depth. And it is very, very rare that we can't get to the depth that we want to. Now, if you have a wellbore that's 6,000 foot total measured depth, or I'm sorry, TVD, total vertical depth, and you're 15,000 foot out, that's a different conversation. In those types of wells, we'll run a hybrid system. So we'll figure out how far we can get out with coil to run our sleeves, and then from that point forward, we'll run a ball drop type system that you can see that through.
That would be like a Tuscaloosa Marine. Well, a Tuscaloosa Marine show, you have vertical depth of 9,000 and then 10.
Yeah, and then you're going to get out 6, something like that. Yeah. If you go to the Permian Basin, you're going to have a lot of wells in the Permian will have a vertical depth of 6,000, 7,000 feet. But there's a lot of operators that are going out 10,000 feet in the horizontal section. And those are very difficult to get out with coil tubing. The rule of thumb is 1 for 1. If I've got 10,000 feet down, typically I can get 10,000 feet out. You know, again, you have to look at each well because it depends on the trajectory of the wellbore. But we look at each well again as an individual.
So the rule of thumb is the horizontal.
The horizontal section, yeah.
Can make the lateral equal to the depth or greater than.
Yeah, I mean, again, that's an operator choice, and what we try to do is work around what the operator's decisions are.
That's interesting.
Yeah.
I've never been.
Yeah. Again, just kind of a rough rule of thumb. So if one of my sales guys is in front of an operator talking to him, and he asks, well, what's your wellbore profile? And if he says, well, I'm 8 down and 8 out, you know, he can think, I can probably get there. But if he says I'm 5 down and 10 out, then it's a more deeper discussion. And that's when we start running our tubing force analysis data.
Can I give you a hypothetical?
Yes.
And Vern, help me out on this. If you were there, were you at the presentation that was monetizing technology?
Not for the whole thing.
Well,
go ahead.
Well, there was a well that Dennis Stegner was talking about. Was the operations guy with Range Resources, and it was a well that had been drilled very successfully. I didn't write down any numbers in terms of depth or laterals, but I think I remember which would be in line with the Marcellus well in that time period of 2009 to 2011, 8 stages. And it had flatlined, but it had flatlined at a pretty good production level. But he wanted to go back in and do a refrac, and it was a hard sell to management to do the refrac, and they did it. And he got a real high, good response to the refrac, to the IP, not a bad decline, but they figured out ultimately when they started looking at the microseismic that they really didn't get an effective refrac in the back half of the lateral, close to the heel, right?
Mm-hmm.
Could you have gone back in there? I mean, could you have, with this technology, could you have said, okay, you got it half right, half of it didn't get refracted, and I asked him, I said, well, will you ever go back into that wellbore again? He said, no. It's going to produce out. But I was just curious, does this technology have any kind of play in a situation like that where they had figured out that a certain number of the stages didn't communicate right?
Yeah, absolutely. We have.
That's huge.
Yeah, no, it is. And you know, so if I look at our sleeve technology, obviously that's only on a new wellbore. Okay, I can only run sleeves on a new well. But our Mongoose system, which again, it's basically our platform. It's our engine to the whole technology. And that's what we launched originally when I told you we took it off the market, and then we did X number of jobs, and continue to grow. You know, and I guess the real easy thing to look at, if you look at on that one of the little handouts I gave you, it says we did 82,508 stages that were placed. Minus that number from the 48,872, and that's how many were sand jet perforating jobs. So we're going in and cutting holes in the casing, either prior to the sleeve technology coming out or to existing wellbores. So now to go back and kind of answer your question, we do have what we call a refrac technology. We have two different systems that we can run. And this is even more so of looking at each well on an individual basis versus cookie cutter. So we would look at a well like that, and we would try to understand, one, what kind of completion did they originally do. So in the Marcellus, typically it's a plug and perf cemented application. Long string to surface, cement in place, then drilling rig moves off, completion comes on, they start shooting holes in casing, setting bridge plugs and coming up. So we would look at that, and we'd say, well, how much spacing is it between each set of clusters, okay? So we can see what type of cement is on the back side of the casing. And if all looks really good, we can go in there with what we call our spot frac system, which is just, again, we take the engine of the Mongoose tool and we add some components to it, and go in there and do a sand jet perforating job, straddle that, and then we would frac down the coil. Okay, so you'd want larger coil, you'd want 2 3/8, 2 5/8 coil, so you can get the highest rate down the coil tubing that you possibly can. Now, if I have blank casing above me, in other words, all my perforations are down below, let's just say it's closer to the heel, you know, and I got some blank casing up there, then I can run my standard Mongoose system, do sand jet perforating, and then frac down the annulus of the casing. So the spot frac system is a cup / bridge plug / sand jet perforating. And then our other system we have is what we call a cup tool, and that's just using opposing swab cups. So we're straddling existing perforations, and then we're trying to do a stimulation down the tubing.
Just fascinating.
Yeah, it's great technology. I mean, we've won 2 awards in the last year from the Oil and Gas Awards banquets. One for the Southwest, and then the other one for the Bakken as being Technology Company of the Year in the Rocky Mountains, and Completion Company of the Year for the Southwest region. Thank you, appreciate that. We just submitted to the World Oil, and we're fingers crossed that we'll win an award or 2 there as well. But we are making, I mean, the success of this company has been quite amazing. We are the fastest growing completions company in the U.S. for sure. I probably wouldn't doubt in the world. And it's because of the technology that we bring to the table. We're bringing something different to the table that gives the operator the highest probability of having the best stimulated wellbore that they can have. We actually have some operators that are right on the verge of restating their EURs, and I think there's one operator that will restate it in his Q3 earnings call. I'd be very surprised if they didn't. And if you get an operator to restate their EURs, you're making an impact in the industry, for sure. And we're very proud of that. So then I'll go back, and like I was talking about earlier, this is all we do. And because this is all we do, we have to be very, very good at it. And going back to look at every well on an individual basis, we're very choosy on the people that we bring onto our team, from their background, will they fit with the team, so on and so forth. and it's working. I mean, it's working great. So it's nice to be a part of an organization like this.
But, along those lines, how many are in Houston, how many are in Chicago?
People-wise?
Pardon?
People-wise?
Yeah.
Yeah, we're, so right now we're right about 200 employees, and all of our manufacturing is done in Houston. The split is probably a 70-30 split, 70 being down in the U.S. and the remainder being in Canada. All of our engineering is actually in Canada. I'd say it's probably closer to a 60-40 split.
Okay.
Yeah.